Hello one and all, welcome to the Mathematic Show. In this one we're going to find the following limit. So it says here, the limit as x approaches 0 of sine 5x over sine 2x. First, let's make a preliminary observation. What happens if you just try to substitute the value x equals 0 into the expression? Well, that's important to review. Take a look. I have sine of 5 times 0 over sine of 2, 0. Just replacing x with 0, that gives me sine of 0 over sine 0, which is just 0 over 0, which is d and e. So there's a problem. You're going to do that check first just to find out what the problem is. In this case, it's not defined because of division by 0 in the bottom here. That tells me that I got to rewrite the expression in some fashion. Okay, let's take a look at the next step. So, I'm going to use a common rule, which is quite applicable here, which is that the limit as x approaches 0 of sine of f of x over f of x equals 1. There's another version of this rule that says the limit as x approaches 0 of f of x over sine of f of x is also equal to 1. So I've written one of these, but you can also imagine the flipped version where the f of x is on top and the sine of f of x is on bottom. It works the same way. It's also equal to 1. I'm going to try to make what I have at step number 1 conform in appearance as much as possible to step number 3. So I can make use of that limit, well-known limit that's equal to 1. So let's take a look at what I'm doing here. Here, when I go over to step 4, let's make sure we understand what I've done so it doesn't seem arbitrary. For example, I'm multiplying essentially by the number 1. Remember in math, you're allowed to multiply by the number 1. There are infinitely many forms of the number 1, and in different contexts, different forms of that number are useful. In this form, take a look. I'm multiplying by this one. I have 2x up here because that will match the sine 2x on the bottom in the sense that this is 2x over here and then sine 2x is right here. Then because I have sine 5x here, so I have a 5x in that position, I have 5x on the bottom. Now, x divided by x, that will cancel. That's actually 1. Think about that, right? This 2 divided by that 2 will also cancel. It's 1. The 5 and the 5 divided give you a 1. So in reality, this 5 times 2 times x over 2 times 5 times x is just a form of the number 1. That's all it is. That's all it can ever be. Otherwise, you would be multiplying by something different and fundamentally changing the expression, you see? That's not allowed. Unless your goal is to change the expression for some reason. So here, what I'm going to do now is apply the famous commutative property of multiplication, which allows you to just, regroup things as you need. So specifically, take a look. When I go from 4 to 5, I took the 5 over the 2, and I moved it outside the limit. That's a constant, essentially. It goes out the limit. Then I grouped the 2x with the sine 2x, so that gives me 2x over sine 2x. And I grouped the 5x together with the sine 5x, that gives me sine 5x over 5x. And all of this is designed this way, because that says then I can apply essentially the famous limit at step number 3. Famous, well, mathematically speaking. And then after that, when I transition from 5 to 6, what I essentially have is the fact that 2x over sine 2x and sine 5x over 5x at 5 there at step 5 are being multiplied. So I can take the limit and distribute it to each factor in the product. Remember, the things that you multiply together are called factors. I have at step number 6, 5 halves, that's a constant outside the limit. And I have 2x over sine 2x, and the limit as x approaches 0 of that quantity, that will be equal to 1. And the limit as x approaches 0 of sine of 5x over 5x, that will also be equal to 1. So that basically takes me to step number 7. At step number 6, both of those limits are found using basically what I'm telling you at step number 3, which is this rule. Sine of f of x over f of x, and the limit as x approaches 0 is 1. So you can also remember there's a flipped version of that that says the same thing. The f of x can be on top, and the sine of f of x can be on bottom in step number 3. It works the same way in terms of the limit value. So now I have 5 halves times 1 back at step 7. So the answer then is, in the end, it's simply equal to 5 over 2. Now, I hope you make an observation here. Here's the observation. Go back to step number 1. It says sine 5x over sine 2x, step number 1. And you see these constants, the 5 and the 2, those are pretty much the same constants that became the value of the limit. Look, so the answer is 5 halves. That's not an accident. So is there some more general principle lurking in the background here? Okay? There is. Take a look. I'm going to go through the same process, but use a more general form of things. So instead of writing numbers in front of x, I'm going to put a and b. So this is going to get a degree more abstract, but that's okay. First, to get good at math, what you can do is study numerical examples, look for a pattern, and then try to generalize the pattern. So that's how I learn math. That's it. There's nothing magical about it from that perspective. So look what happens here. I will have the following. Sine of a times 0, again, I'm checking. What happens when the value of x is 0? So I will have sine of a times 0, which is sine of 0, which is 0 across the top again. Then I will have sine of b times 0. That's sine of 0 again, which is just 0 in the bottom. D and E. Good. Again, I'm assuming, for example, that a and b are values like 2 and 3. Okay. Next one. So again, we're going to make use of this rule at step number 3 that you've seen before. And let's focus on step number 4. That probably is a bit of an abstract leap. So what do we have here? Let's think about this. Because in the top, I have sine of ax. In the bottom, I want an ax right here. In the bottom, I also have sine of bx. So I want in the top bx. And again, notice that despite appearances, this quantity in front of sine ax and sine bx is still just 1. The reason is that a divided by a is 1, b divided by b is 1, x divided by x is 1. So there's nothing arbitrary here. We're not actually changing anything, we're just rearranging things to make them look different so the limits can be found easily. Okay, so if I think about this, what I'm going to do now is regroup, just the way we did with the numerical version of exactly the same concept. So that means the following. The a and the b at step number 4 are pulled out and placed in front of the limit at step number 5. The bx is grouped together with the sine bx, and the ax is grouped together with the sine of ax in the bottom there. As in the previous example, of course, next we might just distribute the limit. So when I do that, I will have ab on the outside, limit as x approaches 0 of bx over sine bx, multiplying the limit as x approaches 0 of sine of ax over ax. Then each of these limits is equal to 1. So in other words, at step number 7 across the top of our black hole, I end up with a over b times 1 times 1. Which means that lastly, the answer is just a over b, the way you see it right here. In other words, back at step number 1, the coefficient on x in the top is a, the coefficient on x in the bottom is b. So at this last step, the value of the limit is equal simply to the ratio of those coefficients, just the way you see it. Okay, and that is it for me. Thanks so much for watching. Please give a like and subscribe, and I'll see you in another video.